Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do another blog post for you. And basically what it is, it's a Kaggle community competition. But in the data set, they gave us all of the images. They gave us the images for the training set, and they gave us the images for the test set. But they didn't give us a sample submission file. So what I did was I went ahead and ran up the test set, and I tried my best to submit my predictions to Kaggle, but because they didn't give us a sample submission file that I could see, Kaggle would not accept my predictions. And I gave the organizers of this competition, this community competition, a comment asking about the sample submission, and they haven't responded to the post. I put a post on the discussion board. And so, I'm under pressure. I really don't have the time to wait around for them to decide to give us a sample submission data set or data frame. And I did my best. I did a sample submission, and I did 1 to 100, and then I did all of the predictions. And so I did my best. And so I'm going to go ahead and do the code review on what I have done, so you can see what I have done. So maybe you can use it with your competitions, or you can use it making predictions on your x-rays. And that's what we're going to do, even though I couldn't submit this work to Kaggle because they didn't give me a sample submission data set or data frame to actually look at to see how to submit my work. And I submitted my work to the best of my ability, but it didn't accept it. And they didn't tell me why they didn't accept it, because you had the image, and then you had something called a mask. So I just predicted on the image, and I didn't include the mask because I wasn't sure exactly what that was. So that's all I did. So I only used half of the images because I didn't use the mask. But we'll go ahead and do the code review. Maybe you'll get something out of the code review. Who knows? And maybe they will answer my question. And if they answer my question, then maybe I can go try to submit my work a third time. So we're using the Automatic Diagnosis of Breast Cancer Community Competition. And this is my work. This is what I have done. So this is the problem statement. This academic competition has the aim to accompany students through the Machine Learning and Healthcare course in the University School for Advanced Studies, Pavia. And I looked it up, and Pavia is in Italy. The target of the competition is to implement a model able to automatically discriminate against malignant from benign lesions in breast ultrasound U.S. studies. So that's what it is. So I did my best. They didn't give me a sample submission data frame for which I could submit my work. So let's just see how it goes. First thing that I did was I created this program in Kaggle's Jupyter notebook, and it's stored in the repository for this community competition. But I will give you a link to the Jupyter notebook in the description box down below. So I'll go ahead and copy this right now. Copy that right now. And then after I created my Jupyter notebook, then what I wanted to do is I wanted to import the first batch of libraries that I was going to use. So we're going to import NumPy as NP, so that's to create your NumPy arrays and do numeric computations. We're going to import Pandas as PD, so that's to create your data frames and undertake data processing. We're going to import OS, which goes into the operating system, and we're going to import Matplotlib, which is a graphics package, and we're also going to import Seaborn, which is another graphics package. And I didn't really use Matplotlib.pyplot, SPLT, or Seaborn in this program, but I go ahead and import those libraries as a matter of course anyway. So after we have imported the first batch of libraries that we're going to use, we're going to use OS to get the files that we need. And as you'll see, if you can see right here on the screen, there is no sample submission. There's no sample submission. The only thing that you get is the images. You get an image of the breast and then an image of the mask, which I'm not sure exactly what the mask is, but every image has a mask that goes along with it, even though I'm not sure what the mask is. And I looked all over for a sample submission, and I couldn't see one, so I don't know if they included it in there, but if they did include it in there, they certainly didn't make it easy to find. Okay, so after we got all of the image, then we're going to set up our path. So train deer, we're going to use path_lib to do that. So train deer equals the path for the training set. Train deer equals path_lib.path train deer, and then you print your train deer. And then test deer equals the path for the test set, and test deer equals pathlab.path test deer, and then we print our test deer. So we've got our two directories, train deer and test deer. So now what we do is we define our classes. So each diagram has a mask that goes with it. I'm not sure exactly what the mask is, but benign equals list brackets train deer.globe benign, and then you get a star.star.png, and then malignant equals list brackets train deer.globe malignant slash star brackets .png, and then you print the number of benigns and the number of benign mask and the number of malignant and the number of malignant mask. And then I also did test image, and test image was difficult for me to do because I had to look it up. I don't use this PathLab very much. I've just recently started working on computer vision, and so it took me a while to figure it out, and I did it in the middle of the night, so I'm a little bit tired this morning because I did it in the middle of the night when I should have been sleeping. But test image equals list brackets test deer.globe, and then it's p question dot png, that's your test image. Test mask equals list test deer.globe, and then it's p star underscore mask png. So a question mark is a wild card, and a star is a wild card as well. So the question mark, and I just really guessed, I wasn't sure what I was doing, and I looked on Stack Overflow, and if you put the question mark in each placeholder of the name, and then the star doesn't matter. So we've got the length of the test image and the length of the test mask. So you have 387 benign, you have 160 malignant, and then you have 100 test image. And I'm not going to worry about the mask. And unfortunately, because the organizers of this competition didn't give me a sample submission, I really don't know whether what I'm doing is correct or not, but I'm going to do my code review anyway. Now we're going to do the print images. So we're going to import matplotlib.image as img and import pil.image as image. And then so we're going to set it up for 2 columns and 1 row, and the subtitle is going to be category. So we check random benign, we create a random number for the benign, and we create a random number for the malignant, and then we read a randomly generated benign image and a randomly generated malignant image, and then we set our title, and then we show it. So you can see here is a benign image, here's a malignant image, and you can see that this is an ultrasound image and not an x-ray. So the benign image just looks hollow, whereas the malignant image, you can see that it has blotches in it. So there we go. Now what we're going to do is we're going to define our train images and our test images. So train images is benign, malignant is malignant, and then the train labels is benign is 0 and malignant is 1. You don't, and then I just said test images equals test image, and you don't have labels for the test because the only thing that they do is they just give you an image, and the computer is supposed to determine whether that image is benign or malignant. And so now what we do is we're going to get a shape of the image. We're going to use import cv2 image equals cv2.imread bracket string brackets train images malignant rand malignant, and then we're going to get the shape of it. It's 437 by 588 by 36. Now what we're going to do is we're going to define our x and our y values. So we create x and y as empty arrays, and then for label images and train images.items, for image and images img equals cv2.imread string image. Resize image, we're going to resize it to 224 by 224, and then we're going to append x with the resized image and append y with the labels, and then we're going to print x and y. So you can see that there's 547 images in total. And now what we're going to do is we're going to resize xtest. So xtest is a blank array for file name in test images. img equals cv2.imread bracket string brackets file name. Resize in img equals cv2.resize brackets img comma 224 by 224. Xtest.append resize image, print len xtest. So you see we've got 100 images. So now we're going to convert these variables to NumPy arrays using NumPy. And then what we're going to do after we've done that, we're going to split our x and our y variables into training and validation set using sklearn train test split function. So x train x val y train y val equals train test split. X, Y, train size equals 0.9, random state equals 42, and then we check the shape of X train, X val, X test, Y train, Y val. And there is no X test, there is no Y test, because they didn't give us the labels for X test. So now we're going into TensorFlow, so we're going to import all of the libraries that we're going to need for TensorFlow, and you can see that we're working on TensorFlow 2.11. And so basically what is going to happen is you need to know what version of TensorFlow you're working on, because TensorFlow has so many changes to it. You need to know what version you're on. So now what we're going to do is we're going to set up a layer in the model that we're going to create for rescaling. So normalizer equals tf.keras.layers.rescaling, scale equals 1/225. So what that does is that takes all the cells and it converts it to a value between 0 and 1. So now what we're going to do is we're going to define our pre-trained models, define the shape for the pre-trained models. So input shape equals 224 by 224 by 3. Input layers equals keras.input shape equals input shape. So we're doing another layer in the model that we're going to create as well. And now what we're going to do is we're going to set up our pre-trained model. We're going to use DenseNet, because the last code review I used DenseNet and I was happy with the results. So I decided to go ahead and use it again. DenseNet equals DenseNet 169. Weights equals ImageNet. Input shape equals input shape. Include top equals false. For layer in DenseNet.layers, layer trainable equals false. So now what we're going to do is we're going to define our model. So what we could do is we could have said input keras.input shape equals 224 by 224 by 3, but I forgot to do that because it was in the middle of the night. So you could have just as easily said input shape, because if you come over here, we've got our input shape already. So I did actually, it was in the middle of the night and I was tired. It was in the middle of the night and I was tired. So really what I could have done is I could have just said input layer. So rather than saying keras.input input shape, I could have just said input layer. And I might go ahead and do that and make it look better. You know, so rather than, so you've got input layer, normalizer, DenseNet, keras layers, flatten, keras layers, dense, 256, activation equals ReLU, keras layers, dropout, and keras layers, dense, num label. So I think what I might do is I might go change it to input layer and then make that easier to read. And then we do our model, summary of the model, so you can see the summary. And then we compile the model. Optimizer is Atom. Loss is sparse categorical cross entropy. Logits equals true. Metric equals ACC. Early stopping, we set it up for early stopping. We set it up for MC. And then we set up all of our, I put it up for 20 epochs. And the val accuracy, what I might do is I might set it up for 30 epochs because it hasn't stopped either. Then we're going to make predictions. Ypred equals model.predict. X test, batch size equals 64, verbose equals 1. Ypred bool equals np.argmax. Ypred axis equals 1. And then we've got our Ypred bool, which we've got a lot of ones and zeros. And then I prepared my submission, and since the organizers of the competition didn't give me a sample submission, I just had to guess. So I just did ID and then 1 to 100, and then submission created a blank data frame. submission ID equals ID, submission label equals white bull, submission to CSV, bracket submission CSV, index equals false, submission equals PD read CSV, submission.csv, and then submission. And so you can see all of the ones and zeros. But unfortunately, I was not able to submit this to Kaggle. Well, I did submit it to Kaggle, and it failed. So, but I'm doing it anyway. I thought, well, I put forth all this work. I'm going to do the code review anyway. It's not my fault that they didn't give me a sample submission frame, and they didn't tell me how I was supposed to submit my work. But I did look on the leaderboard, and the lead people on the leaderboard, they only had like 35% accuracy. So my Jupyter notebook is the only Jupyter notebook that's in the code. So I can't say how they did their sample submissions because I'm the only one that shared my code. So that's going to conclude this code review. I did my very best, and I'm going to make a blog post on it as well. So thank you so much for watching my code review. I hope you got something out of it. The only thing that I couldn't do is I couldn't submit it to Kaggle, and I've explained to you why. Thank you so much for watching my video. If you like my video, please like, subscribe, and share. Thank you to my subscribers for supporting my channel, and I look forward to making more code reviews for you in the future.